All right, it's hello from West Virginia. Still not. But we do have joke of the day, and I know you've been waiting for joke of the day, and here it comes. So I know some people hate math, but really, you've got to admit that decimals have a point. I love that one. Okay, and the other thing that I love is types of equations. Now, there are different types of equations in math, and I know you may be thinking, yeah, we've been doing all kinds of different types of equations. We've looked at equations that have fractions in them. We've looked at all kinds of stuff. Well, actually, you've only been looking at one type of equation. That one type of equation you've been looking at so far is what's called a conditional equation. A conditional equation has a solution, yes, but it might have more than one solution, but the bottom line is it has a solution. So a conditional equation is a type of equation that has at least one solution. At least one. We'll just call it at least one. So here's an example of a conditional equation, and I know you're looking at all three of these going, well, those look like everything we've been doing so far. I don't understand what the difference is. You're about to see. So if we solve this equation, we know that what we need to do is distribute the 4 through, and when we distribute the 4, we know that we will get a 4x minus 8. And we know at this point, let's subtract the 4x from both sides. And when we subtract the 4x from both sides, we get x minus 20 equals negative 8. And we know at this point, let's go ahead and add that 20 to the other side, giving us x equals 12. And so that gives us our solution. And remember, we said a conditional equation is one that definitely has a solution. It actually might have more than one solution, but this is the case where it only has one solution. So we have a conditional equation here, and the solution set, there's several ways to express that solution set. Now, most of us, we just simply write this, x equals 12. But some teachers, some textbooks, some math programs want to really stress to you that you are generating a set of numbers. The set of numbers that we're looking for are the numbers that we can plug in right here and get the left and the right side to be the same. Because when the left and the right side are the same, we have truth. And so we're looking for a set of numbers that will work. Well, at times there are more than one number that will work, but at times there's only one number. But it is a set of numbers. So in order to express this in set notation, we always use parentheses, but we use braces to express set notation. So we would express it as our solution is simply the number 12. So your solution set then, you can write it as simply the set with the number in it, or you could potentially write the variable equals whatever that number is. But like I said, more often than not, we just simply write this and it's perfectly fine. I just want to really emphasize to you, if you see the braces, it is because your textbook, your teacher are really trying to emphasize to you, this is a set of numbers. It just happens that there's only one number in that set, and that's perfectly fine. So let's compare the conditional equation with the other two types of equations. The next type is what we call an inconsistent equation. Now, an inconsistent equation, watch what happens here. Looks very much like every other type of equation, so we know in order to solve it, we're going to distribute first. And when we distribute, we're going to get 5x minus 20 equals 5x minus 50. We're going to subtract that 5x from both sides. Now be very careful here, guys. Think about this. This means in this pan, we have 5 x's. And in this pan, we have 5 x's. So if I'm taking out 5 x's here, I don't have any x's left in that pan. They are completely gone. The only thing that I'm left with is that negative 50. And in the same light, if I take 5 x's out of here, I just took all of them out of the pan. I don't have any x's left. I'm left with a negative 20. And people have a heart attack when they see something like that. They go, oh my gosh, the variable's gone. The variable can't be gone. I can't lose that variable. You can. It's okay. The mistake that I see all the time, I've been doing this for a very long time, the mistake that I always see is people, they freak out and think they have to have a variable, so they go like this. They say, well, I'm just going to put my x over here because we always see the x over there. But like I said, think about this, guys. You had 5 x's. You just took every one of them out. You don't have any x's left. So you cannot put this. This indicates you have 1 x left. but you don't have any x's left. So I'm going to get that out of there because it's not even in there. So I'm left with a negative 20 equals negative 50. Now remember, the idea is I'm trying to figure out what can I put right here and right here and create truth. And that truth is going to be that the left side and the right side are going to be equal to each other. So what can I plug in and create truth? Well, here, this said what I can plug in is a 12. This says x is 12. X is 12. So that means that I can put a 12 everywhere that I see an x, and that will create truth. But down here, I don't see anything that says x equals something. So I can't figure out what x is. And some people say, well, let's call x a negative 20. Well, if you put a negative 20 in here, 5 times negative 20 is a negative 100. Negative 100 minus 20 is going to be a negative 120. If you put a negative 20 right here, negative 20 minus 10, I'm following order of operations. It says do in the parentheses first. Negative 20 minus 10 is a negative 130. 5 times negative 130 is a negative 150. See, the two sides are not the same. And some people say, well, all right, let's put the negative 50 in there. Well, 5 times negative 50 is a negative 250. Negative 250 minus 20 is going to be a negative 270. And if I put the negative 50 right here, negative 50 minus 10 is a negative 60. 5 times negative 60 is a negative 300. Are they the same? Did we create truth? No. And some will say, put the 0 in. Well, 5 times 0 is 0. 0 minus 20 is a negative 20. And then when we put the 0 over here, 0 minus 10 is a negative 10. 5 times negative 10 is a negative 50. Still not creating truth. So my dilemma is, okay, what will go in there? Well, guys, you could throw numbers at me all day long. Every number you throw at me, we're going to put it right here, we're going to put it right here. It's not going to create truth. So if we could be here all day throwing numbers in there and none of them are going to work, then what is my solution? Exactly, I don't have a solution. So in other words, the number of solutions, I don't have any, none. Well, if that's the case, then how do I express my solution set? Because remember, I'm generating a set of numbers here. What will go in here? Because remember, what goes in there is the solution itself, like we saw before. 12 was the solution, it went in there. But I just said there aren't any solutions. So what am I going to put in there? Exactly, I'm going to put nothing in there. I have an empty set. Now, another way that we can express empty set, the way that most people like to do it, is this symbol right here. This is what we call the null set, also called the empty set, because it is a representation of this set right here that is the set that is empty. Now, what you never want to do, and I see this mistake a lot of people will go like this. They'll take their empty set and then they'll put the null set inside of it. But think of it this way, because the set, the braces indicates like a bag. And so it's saying, okay, I've got this bag and I have nothing inside of my bag. So I've got a bag sitting here, but there's nothing in it. But this one says, okay, I've got this bag right here. So here's my bag, and I just put another bag inside of it. Now that bag is empty, but I put a bag inside of a bag. That is not at all what we're trying to say here. We're trying to say one bag that is empty. So you don't want to do anything like this, definitely not. You either want to write this symbol or this symbol, not a combination of the two. So my answer for this one then is going to be my empty set, which like I said, most people will write it this way. So now let's take a look at the last of my types of equations. And this is what we call an identity. Now, an identity, take a look at this equation. We know that to solve this, we're going to distribute that 5 through. And remember, I'm going to distribute it all the way through the parentheses. Do I distribute it beyond the parentheses to here? No, you're smart. You know not to do that. All the way through, but to the end of the parentheses, and then you stop. That's as far as you go. So when I distribute through, I'm going to get a 5x minus 10 minus 10. Now, we're going to collect those like terms. That negative 10 minus 10 is going to be a negative 20. And I'm going to get a 5x minus 20 on this side and a 5x minus 20 on that side as well. I'm going to subtract those 5x's like we described before in the previous one. And when I subtract the 5x's here, remember, I had 5x's. I just took every one of them out. I don't have any x's left. They are completely gone. That leaves me with a negative 20. Now over here, when I take those 5x's out, again, There were 5 x's. I just took every one of them out. Do you have any x's left? No, you don't. You're left with on this side as well a negative 20. And so now I'm going, okay, remember, the goal is figure out what can go here and create truth. Truth will be that whatever I come up with over here is going to be the same thing that I come up with over here. That's truth. And when I have truth, then I have my solution. So what can I plug in here? All right, yeah, let's try that negative 20 that's sitting there. 5 times negative 20 is a negative 100. Negative 100 minus 20 is going to be a negative 120. And when I put that negative 20 here, negative 20 minus 2 is a negative 22. And 5 times negative 22 is a negative 110. And negative 110 minus 10 is a negative 120. All right, I got the same thing on both sides. But you know what? Let's try some other numbers. What if I put a 0 in here? Well, 5 times 0 is 0. 0 minus 20 is a negative 1 or negative 20. What if I put a 0 in here? 0 minus 2 is a negative 2. 5 times negative 2 is a negative 10. Negative 10 minus 10, oh, it's another negative 20. What if I put 100 in there? Positive 100. 5 times 100 is 500. 500 minus 20 is going to be a 480 and a positive 480. Put that 100 in here. 100 minus 2 is a 98. 98 times 5 is going to be a 490. And 490 minus 10 is, going to be another 480. I got the same thing on both sides. And you know what? Again, we could be here all day long. Every number that you throw at me is going to work here and here. Every single number works. And so how many solutions do I have? How many? Well, infinitely many. If we're talking about every number, then I have infinitely many solutions. Infinitely many. But how do I express my solution set? Now remember, this is a set of numbers that we're generating, and we're saying every single number works. So there's several ways to express this. One way is to say, okay, I'm going to do the set of all real numbers. Another way to express it, the more beautiful mathematical way to express it, and I'm going to run out of room up here, so I'm going to put it over here. The other way to express it is to say x such that x is a real number. Most people don't write it that way because it's a little bit much. But once again, the braces indicate set. And so we have the set of all numbers, whatever that variable is that you've got in there, you put it in there. And the same thing up here, whatever that variable is, you put it in there. So the variable such that, whatever that variable is a real number. This is the more mathematically perfect way to express it. So we've got this way, we've got this way. And the way that most people like to do it is they like to do this symbol right here. The capital R with 2 bars in it indicates all real numbers. And so that's what most people do because, hey, why would you write all that out when you can just do this? So that's what I'm going to express as my solution set, all real numbers. Now, let me give you a couple of tidbits that can help shorten your work for you. Remember, what happened was I came down here and I said, okay, I don't have x equal to a particular number. My x is gone. And the same thing happened down here. My x was gone. But notice that once the x was gone, I looked at this statement, and that statement was a false statement. Well, whenever you come up with a false statement is going to indicate you have no solutions. So your inconsistent equation is the type that you get a false statement in the end. And whenever you get that false statement, that's when you can stop. And you can say, oh, it's no solution. I'm done right here. And the reason I point that out is because a lot of people who think outside the box very well, and I don't think outside the box very well, I would come right all the way down to here. But those who think outside the box really well, they could stop right here. Because as soon as they hit that spot, they're going to notice I have a 5x on both sides, but I have different constants. And so they know that as soon as they drop that 5x, they're going to get a negative 20 equals negative 50. So people who think outside the box, they could stop right there and go, it's no solution. I'm done. And that's perfectly fine. Similar idea down here. Notice that when those variables were gone and we came up with this, that's a true statement. Because negative 20 is a negative 20. Negative 20 is always going to be a negative 20. And so right here, whenever you come up with a true statement, that's what an identity is. It is a true statement. And as soon as you get that true statement, you know that you have an identity. You know that that means all real numbers is going to be your solution. So in that case, as soon as you see that true statement, you can quit. And once again, those who think outside the box really well, they're going to see it right here. Because they're going to know, I'm going to drop those 5 x's, I'm going to get that negative 20 equals negative 20. As soon as they recognize, or as soon as you recognize that you have the same thing on both sides, you can quit and you can say, my answer is all real numbers. Because some will recognize it right here. In their head, they'll know a negative 10 minus 10 is going to be a negative 20, and they can stop right there and say it's all real numbers. The whole point is, when you wipe out that variable, and the variable is completely gone, and you have a true statement, you have an identity, that means all real numbers will work. If when you wipe out that variable, the variable is completely gone, and you have a false statement like you see right here, false statement indicates inconsistent. That tells you no solution is your answer. Nothing will work. And if you do not wipe out the variable and you've got your answer, well, ta-da, it's a conditional equation. You have at least one solution. And like I said, in other videos much later, you'll see cases where we have more than one solution. But for right now, we only have one. So I hope that helps you with the types of equations. And hopefully now you understand, there really is way more than just this type of equation. Because now we've got some where nothing works and we have some where everything works. I hope that helps. Have a great day.